Hello, guys. Thank you so much, guys, to join us today. We are looking at the question paper that was written last year, the year 2022. So we are looking at question 5. That was actually the topic on the work, energy, and power there. So please, guys, make sure that you subscribe with us so that you can be able to receive as much content that is going to help you as possible. Yes. So let's read the question. Question 5 says a 12 kilogram block. Let's read there. 12 kilogram block. We're just going to go a little bit down. 12 kilogram block. It's initially at rest from point A at the bottom of a rough inclined plane. So the surface is basically going to be rough, and then the object here, it's still initially at rest, so it means the initial velocity of that object at point A is 0 there. And then the mass of the object, yes, is 12 kilograms at the bottom of a rough inclined plane. The block is pulled up the incline by a constant force F acting parallel to the incline. That is very much important, acting parallel to the incline. The block reaches point B, which is a vertical height of 4.5 meters. This one basically, gives us an idea of the gravitational potential energy there above the horizontal with a speed of 2.25 meters per second. Another variable that gives us an idea in terms of the kinetic energy of the object. All right. So, yes, guys, the first question there, it's a theoretical question. It says define the term conservative force. What is a conservative force? Yes, what are define the term non-conservative forces. We remember we've got conservative forces and also non-conservative forces. So examples to non-conservative forces are basically contact type of forces like your frictional force, your applied force, your tension, your air resistance, anything like any type of a force that that has to be in contact with between the surface and also the object for it to move the object or just to interact with the object. It depends with the dynamics. So those are the examples, and let's read from the examination guideline the definition there. And remember, that's basically 5.1. The definition says define a non-conservative force as a force for which the work done in moving an object between 2 points depends on the path taken. So that one depends on the path taken. And as I said, your examples are going to be your frictional force, your tension, and also applied force and air resistance. Air resistance is basically another, it's basically a form of a frictional force. Then we accumulate the 2 marks there. Thank you so much for the 2 marks. Just going to accumulate the 2 marks there. All right, so let's go to 5.2. 5.2 says draw a labeled free body diagram for the block when it is pulled up the incline. So I'm just going to try to draw them here as 5.2. We are going to look at this one here. Yes, we draw down here, and then it's gonna be a frictional, a weight, or you can call it a gravitational force. Then the other one, we're gonna draw it here. This is the applied force, and then we're going to draw it here as your FK, and we're gonna draw it here as your normal force. Okay, so these are the 4 forces. Our question is basically 4 marks, so it means we need to provide 4 number of forces in that case. I think by here the question is out of 15. If you get these 2 marks, you have got 2 plus 4, that is 6, and I want to believe that 6 is basically 40% of this question. So it means if you can answer these 2 questions, then you have got a level 3 already. You're moving into the space of passing. All right, so let's go to the next question. That is going to be question 5.3. 5.3 says calculate the total work done on the object by the non-conservative forces when the block moved from point A to point B. The word total the word total work done basically speaks about the net work done. It's basically the same thing. So in other words, they're looking for the work done by the non-conservative forces, because this formula that says WNC equals to change in your EP plus change in your EK. That formula basically speaks about the work done by the non-conservative, is the net work done by the non-conservative forces. So we're going to have MGH at B minus MGH at A. We're going to have half MV at B squared, and then minus half MV at A, then we square. Equal sign, can we substitute? We are calculating the total work done by the non-conservative forces, by the NC. So you've got your 12 times 9.8 multiplied by 4.5 minus 0. This one, it's going to be 0 because the height there equals to 0. And then plus 1 over 2 into 12 into 2.25, you square, minus a 0 there, because the initial velocity of the object at point A equals to 0. So pressing your calculator, you've got 559.58 of joules there. Remember, work done is measured in joules, so we're going to have 559.58 of joules of work done by the non-conservative forces. So, and the other thing that you need to do, guys, sometimes you need to mention the very same non-conservative forces that the examiner is talking about. So one thing for sure that I know, it's your FK is going to be a non-conservative force. It's basically this one, and also your applied force there. Both of them are going to be your non-conservative forces, because the FG parallel, it's going to be your conservative force. All right. Okay, so let's go to 5.4. The leading statement for 5.4 says the same constant force, F now moves the block at a constant velocity. What does this mean? According to Newton's second law, we know that F net equals to 0 there. F net equals to 0 across a rough horizontal surface from point B to point C, as shown below. Force F acts parallel to the horizontal. That one is very much important as well. The magnitude of the constant frictional force acting on the block while moving from point B to point C is 42 larger. Wow. Some people are going to take the 42 and multiply the frictional force between A and B. And, I don't know, but you cannot multiply them. You just have to add. It means if, the frictional force here is Fk, it means this side, the frictional force will be Fk plus your 42. Then that is going to be the frictional force taking place that side. So, guys, we are going to model this like this statement. But for us to be able to model them, let's start with what is happening at BC. So Newton's second law says F net equals to 0 there, because there is basically the statement that says at a constant velocity. When the speed of the object is constant, then we know that acceleration equals to 0. Then your net force also equals to 0, and also the net work done, it's gonna be 0 there. All right, so thank you. Then from there, let's look at what is happening. So when you draw a free body diagram of this object here, you're going to have something that looks like this. Please, bear with me. The arrows there are not so right, and also that one. So you've got your F, and also you've got your FK plus the 42. So it means if you represent this one and that one in terms of your Newton's law, you're going to have F minus in bracket. You're going to have your 42 plus your Fk equals to 0 there. And then from there, F minus 42 minus Fk equals to 0. We are transposing the 42 to the other side. F minus Fk equals to 42 because, and then we have got this one is equation 1. So I'm trying to write this one in terms of the resultant force. I don't know what's going to happen when I'm trying to do the representation between A and also B. A and also B. However, we just have to, go back and read so that we understand. So the same constant force now moves the block at a constant velocity, the same constant force across a rough horizontal surface from point B to C as shown below. Force F acts parallel to the horizontal surface. The magnitude of the constant frictional force acting on the block while moving from point B to point C is 42 newtons large than the magnitude of the constant frictional force acting on the block when it moves from point A to point B. So in other words now, the net work done for this object, on this object to move from A to B has not changed. So it's just going to be the same, thing as the one that we calculated on top. It's going to be your 599. So it's gonna be your 559.58 of your joules of work done there. So okay, let's see what we can do. And remember the word WNC. If you've got the word WNC, basically is the same as net work done. So the net work done equals to, this is basically according to my understanding. I'm just putting out my understanding of this question and suggesting how best you can solve this problem. The net work done now, it's basically equals to the work done by F plus the work done by your Fk there. All right. So the work done by that and that. So now 559.58 equals to, we're going to represent this as F changing X and then cos of theta, and then plus we're going to have this as your Fk changing X cos of the angle theta there. So 559.58 equals to, we're going to have F changing X and then cos of 0 degrees plus Fk changing X and then cos of 180 degrees, because the frictional force is basically opposing the displacement there. And in this case, it's 0 simply because the applied force is in the same direction as the displacement. All right, so we're going to have 559.58 equals to, this one is just going to be F changing X because cos of 0 equals to 1. And then this one is going to be minus Fk change in your X there. So what I'm going to do, I'm going to have 559.58 equals to, I'm taking out the change in X as the common factor there. So F minus Fk. Oh, wow. So this is now going to be equation number 2. And then up there, remember, from up there, remember we said that, equation 1, we said it's F minus 42. It's basically F minus 42 minus Fk equals to 0. And then F, okay, just want to substitute. I just want to substitute, that as your F minus 42 minus Fk equals to 0. And then F minus Fk equals to 42. So the value of 42 is basically F minus Fk. Then we are going to drag this equation 1. we're going to substitute it into equation number 2. So we're just going to do this, and then we are taking it to this one. I hope people are able to follow them. 559.58 equals to you're changing x into your 42, because equation 1 there we said f minus fk equals to 42. Then we divide both sides by 42. Yes. And then changing x equals to, we're going to have 559.58 divided by your 42. Then this is going to be 13.32. 13.32 of meters. Then this is going to be my suggested answer. Wow, such quite a lot of mathematics that is taking place there, guys. Please, that is the answer. Please don't forget to subscribe. It is not a difficult thing. You need to keep on working and working and working. So understand what you're doing. I think it's very much important and key for you to basically understand what you're doing there. So thank you, guys. Thank you so much. Thank you so much. And please, guys, don't forget to subscribe to the Blue Star YouTube channel. A lot of content that is coming. We're really going to prepare you guys for your upcoming examinations. We are actually in the mission of nailing. You understand what I mean? Just to kill the 2023 November papers, both mathematics and physics. We are going to do well. Thank you, guys. Subscribe and all the best. Share with your friends and cousins. Bye bye.